Hi, I am using Workbench 16.1 Ansys program to draw and analyze any object. Now I'm going to take a rectangular cantilever and start to drawing it. Now I'm waiting. In the beginning we will have this windows, the toolbox. You can get in any one of these. Ansys can offer you to go in any design, like in fluids, IC engines, look, models, which is about vibration, look, random vibrations, static structural, which is commonly used by many designers, thermals, transient structural. You can many fields can use this program. In the other side, right side, you will have the project schematic. Here you will have the project of you. The welcome windows appear to you. Okay. To start working in any of these, I am going to work in the model to find the natural frequencies and mode shapes. I'll drag the model by the mouse to the project schematic, or I can use or I can double click on it to show this list: model, engineering data, geometry, model, setup, solution, results. Here the program offers me the name of this file. I'll choose any name, like my name, Tariq 1. Enter. Then I'll begin with the geometry or engineering data. Engineering data, this is, you will find the materials in this program and its specifications. When I make double click on it, look, the program offers you a default material, which is the structural steel. You can choose any material you want by go to engineering data source here, click here, data source. You have favorite, if you can make some materials favorite for you, or you can choose general materials, general non-linear materials, and others, explicit material, hyper elastic, and so on. If I open the general materials, here in the upper window, you will see the air, aluminum alloys, concrete, copper, gray, cast iron, magnesium, etc., stainless steel. I can choose any material in addition to the default one, which is the structural. I choose aluminum. Then I click the plus sign here to add it to my materials. Now click, look, I have aluminum alloy and structural steel. After that, I can close the engineering data here and return to the project. You will, when you complete one of them, you will see the signal of correct, of completion. Now I'll try to draw my project. Go to geometry, double click, waiting, start design modeler, as you see here. When the screen is opened, I'll choose XY plane. uh, right click and choose look at. You will see this man is looking to a screen. Here your axis will be in front of you. You can use this icon, the same look at. After that, you will have to pay attention that the scale of the scale of the screen is in meter, which is so long for, especially for mechanical. Maybe civil engineers can use this, but for mechanical, we use the millimeter. I go to units and select millimeter. After that, I'll begin to draw my project. Going to sketching, I can choose rectangle or any, try to use the line and draw what I want. For simplicity, I'll choose rectangle. After that, I'll put the dimension, go to dimension. Here I have H1, here I have HV2. This horizontal and vertical, you can use it when the two nodes are not at the same level, and or the line is inclined. You don't want to measure the inclined line, but the vertical or horizontal distance between the two nodes. But if you want to measure horizontal or vertical lines, you can go directly and put them. When I apply these dimensions, I'll go to this windows and write my dimensions. I maybe use 50 millimeters, equal to 5 centimeters, and the V2, the vertical, may be 10 millimeter. Now I draw my object in 2 dimensions. I am now trying to extrude this. I go to this ball, click the ball, you will see your object is become in 3D view. Look, 3D view. Now I'll go to extrude. Look, the program offers you an exclude. Now I'll go to depth and change the value from 30 to about half meter, which is equal to 5, or I'll choose 300 millimeters. Look, the extrusion is out of the screen. In order to make my object within the screen, I'll go to zoom to fit. Before that, I'll choose, or now I'll make generate. Look, I generated my object. After that, I can close this windows, close design modeler from file. Now I closed my geometry. Return back to engineering data. I'll see I have aluminium. From here I can go to project, or it's not important. I'll go to the model to in order to make mesh and to make the apply the support and the load if I want. Double click to model, waiting for the program, still waiting. Here the my project. I'll make the mesh. In order to make the mesh, I'll choose the body. The body. Before that, I'll see the material from geometry, solid, the material. Here, the assignment, the material is structural steel. If I want to change it, click this black arrow here. If I have a new material or import a material or edit the properties of structural steel, or go to choose the aluminum alloy as I involved in the first steps. Here my material is aluminum alloy. After that, I'll go to mesh. To make mesh, right click, insert. If I want the default, I can choose mesh directly, but I want to change the size of the mesh. Sizing. After that, I'll go to element size. Here you have to notice something, that the scale is returned to meter, because when I have made the extrusion, it was so long. Then the program automatically made the scale in meters. So when I put the size of the mesh element, I'll put it in meters. So I'll choose 5 millimeters, which is equal in to 0.005 meter. Enter. After that, going to mesh, right click, generate mesh. Look, this is my mesh. After that, I have to put the the fixed support, which is in this direction or face. So I'll go to model, right click, insert, fixed support. Now I'll rotate my object to make the face that I want in front of me, and then select face, look, face, and here I select this face. After that, I have to make apply. This is I have done. To retain my the object to its original state, I'll press the ball. Here, the ball. Look, I have made. After that, I'll go to analysis setting. In analysis setting, I'll see the maximum mode to find 6. This means that the program will, when solve this problem, he will give me 6 mode shape. I can increase it or decrease it as I wish. 6 is a good indication in the field of vibration, so I'll keep it. After that, I'll go to solution, right click, and insert the insert. Before that, I don't I made it the insert. Now solution, solve. Now the program is solving. Still waiting to finish. Okay. Now you can see here with me that the mode shape, I have mode shape and the frequency in hertz. The first mode shape, which is called the fundamental natural frequency, is 91 point something. The second is 446. The third, fourth, fifth, and sixth. Here, look, I can right click, select all, then again right click, create mode shape. Here I'll have the total deformation, which is the mode shapes that I'll get it from the solution. I'll go to solution, right click, and choose evaluate all results. Now if I choose the total deformation 1, you see this is the natural frequencies, the mode shape first. I can run it to see the movement of the mode shape. The second one, this is the second one, its vibration is in another direction, which is XZ, not YZ. The third, look, this is the third. This is another mode shape. The fourth, here, the fourth is a rotation. A rotation what? The fifth mode, and the last one is the sixth. Look, it's in. Okay, that's all. Thank you for